Okay, geometry students, in this video we will be studying how the four special pairs of angles that are formed by a transversal relate to parallel lines being cut or intersected by a transversal. By the way, in geometry, do understand and get used to this word right here, cut, being used for the word intersected. Okay, that's very, very normal. And remember, these four special pairs of angles that I'm talking about, we just learned the other day. It was what? Consecutive interior, alternate interior, alternate exterior, and corresponding angles. So we're going to look at those four special pairs of angles and how they relate to parallel lines when parallel lines are cut by a transversal. Remember the other day we studied this. The lines were not necessarily parallel. They looked like this, and then a transversal like this. Today, this line here and this line here is going to be parallel, and so that's what we're going to look at today. Okay, if you didn't get all of that, that's fine, but I'll explain that later. But that's what we're going to look at today. So if you would please go ahead and write this heading in your notes: properties of angles formed by transversals and parallel lines. Copy that down, please. Properties of angles formed by transversals and parallel lines, lesson 3.5, and include today's date, please. I'll pause just a second while you copy that down. Properties of angles. And what angles is that? Angles formed by transversals and parallel lines. So we're looking at the properties of angles and parallel lines. And what type of angles? Angles that are formed by transversals. Okay? Okay, this heading will stay up here. Let's go ahead and continue on. We will be looking today at one postulate and four theorems. Okay, one postulate and four theorems. We're going to prove one of these theorems. Okay, contain your excitement. Let's start with the first postulate. Okay, would you copy this in your notes, please? This is postulate number 15. So we have now learned 15 postulates this year, and the name of the postulate is the corresponding angles postulate. Okay, the corresponding angles postulate, and it reads as follows. If two parallel lines are cut by a transversal or intersected by a transversal, then the pairs of corresponding angles are congruent. Okay, copy this in your notes, please. You're responsible for this postulate. If two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. Okay, copy that in your notes, and then when you're done, I want you to take really good notes on this picture, okay? So here we go. Take really good notes, please. Here's a line. Here's a line. Go ahead and put a parallel symbol on there if you would, please. So put an arrow there and an arrow here. That means the two lines are parallel. And we'll go ahead and put a transversal here, all right? And we'll call this line A. We'll call this line here L, and we'll call this M, all right? So here's what we have. Oh, and let's put some angles here on the diagram. I apologize, students. Let's put we're doing with corresponding angles. So let's put a 1 here, a 2 here, a 3 here, a 4 here, a 5 here, a 6 here, a 7 here, and an 8 here. So please fill that in if you would, please. And then here's what we're going to say. Okay, copy this down carefully. If L is parallel to M and A is a what? Transversal. Got it? So if we have two parallel lines and A is a transversal, then what happens? Corresponding angles, here it is, corresponding angles are congruent. Okay, so write that down, please, right here. We're going to put angle 1 is congruent to angle 5. Angle 2 is congruent to angle 6. Angle 3 is congruent to angle 7. And angle 4 is congruent to angle 8. Do you see that okay, students? 1 and 5 are corresponding. We learned this in the last video. 2 and 6 are corresponding. 3 and 7 are corresponding. And by the way, when I taught that video showing you all of those four special pairs of angles, I told you guys then you would really need to know that well, and now you're seeing why. 4 and 8 are corresponding angles, okay? So, last time, if two parallel lines are cut by a transversal, the corresponding angles will always be congruent. You need to know that. Here it is in words, and here it is in a picture form. You need to know that, okay? All right, I'm going to pause a couple more seconds. If I ever go too fast, just let the supervising teacher know and they can back the video up, okay? All right, let's move on to our next theorem, which is Theorem 3.6. Okay, so we're looking at one postulate today. There it is, check, and then 4 theorems. Okay, so our first theorem of the day is this. Please copy this in your notes. Theorem 3.6, alternate interior angles theorem. If 2 parallel lines are cut by a transversal, then the alternate interior angles are congruent. So it's the exact same thing as the last postulate we looked at, only now instead of dealing with the corresponding angles, we're dealing with the alternate interior angles. So copy this in your notes. If 2 parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. Okay? All right, let's go ahead and get a picture of this up here, which we definitely need. So here we go. There we go. And I guess we'll go ahead and draw our same angles up here again. Let's go ahead and let's just keep everything the same for all of our drawings. A, L, M, 1, 2, 3, 4, 5, 6, 7, 8. Okay? So here's a picture of the theorem. If L is parallel to M and A is a transversal, then let's see, alternate interior angles. Let's circle those in green. Let's see here. Alternate interior. 3 and 6 are alternate interior, and 4 and 5 are alternate interior. So we can state that angle 3 is congruent to angle 6, and angle 4 is congruent to angle 5. And that's it. Those are your 2 sets of alternate interior angles. So again, one more time. If 2 parallel lines are cut by a transversal, then the then the alternate interior angles are congruent. Okay? And here they are. 3 is congruent to 6 and 4 is congruent to 5. Alternate interior angles. If I'm going too fast, just have the teacher pause the video. Okay, let's go ahead and move on and take a look at Theorem 3.7. Okay, Theorem 3.7. Slide this up so we have some room, and here we go. Okay, students, Theorem 3.7. Here we go. Please copy this in your notes if you would, please. You're responsible for this theorem, and it reads as follows. It's called the consecutive interior angles theorem. Students, please listen to me. We're going to look at one postulate, okay, and 4 theorems. Got it? Only one of these is going to give you angles that are supplementary, okay? So this is the only one in which they state that a certain type of angle is supplementary, all right? So keep that in mind, students, as we go through these theorems, okay? So here we go. The consecutive interior angles theorem, if 2 parallel lines are cut by a transversal, then the consecutive interior angles are not congruent, they're supplementary. And that's where students mess up all the time in this class. In geometry, they think they're congruent. The consecutive interior angles are supplementary, okay? So I'm going to pause a second while you copy this down, then we'll go ahead and look at the diagram, the picture. Theorem 3.7, the consecutive interior angles theorem, okay? All right, and here we go. So we have a line here and a line here and our transversal. Let's keep everything the same. We'll call this A, we'll call this L, we'll call this M. Trying to make this as simple as possible, students, for you to see. And here we go. If L is parallel to M and A is a transversal, which it is, then now be careful here, then the consecutive interior angles are supplementary. So 3 and 5 are consecutive interior angles. So angles 3 and 5 are what? Supplementary. And then the other two consecutive interior angles would be 4 and 6. Okay? So angles 4 and 6 are supplementary. Okay, so there we go. That is all that Theorem 3.7 is saying. It's simply saying if you have two parallel lines cut by a transversal, the consecutive interior angles are supplementary. So in other words, these angles will add up to 180 degrees. Okay? All right, let's continue on and look at our next theorem. Okay, students, please copy this in your notes. I'm going to slide this up to get a little bit of room. And here we go, Theorem 3.8. This is called the alternate exterior angles theorem, and it reads as follows. If two parallel lines are cut by a transversal, then the pairs of alternate exterior, that should be exterior by the way, that's a typo, so please understand that, exterior angles are congruent. Okay. If two parallel lines are cut by a transversal, then the alternate exterior angles are congruent. Okay? Copy this in your notes if you would please, and I'll pause a second while you do that. Theorem 3.8, the alternate exterior angles theorem. Okay? All right, here's a picture of this theorem. Let's go ahead and put our two parallel lines, and we'll put a transversal here, and we'll call this L, and we'll call this M, we'll call this A, and we'll say if L is parallel to M, and A is a transversal, which it is, then, and I forgot to number my angles, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. The alternate exterior angles are congruent. So 1 and 8. So angle 1 is congruent to angle 8. And angle 2 is congruent to angle 7. And there we go. 1 and 8 are what we call alternate exterior angles, and 2 and 7 are what we call alternate exterior angles. Okay? So, again, if two parallel lines are cut by a transversal, then the alternate exterior angles will be congruent. Okay? I'm going to pause for a second while you finish your pictures here, your diagram, and then we'll continue on. Okay, last theorem. Please copy this in your notes if you would, please. Theorem 3.9. I'm going to slide this up a little bit to get some room. And here we go. Please copy this in your notes if you would, please, students. Last theorem. And then we're going to prove a theorem. And then we're going to look at about 3 or 4 problems to give you practice using these theorems. And then we'll be finished with the video for today. All right? Theorem 3.9. If a transversal is perpendicular to one of two, let me fix that please, parallel lines, then it's perpendicular to the second. Alright, so please copy this down. Now this has nothing to do with angles, as you guys can see, okay? If a transversal is perpendicular to one of two parallel lines, then it's perpendicular to the second, okay? If a transversal is perpendicular to one of two parallel lines, then it's perpendicular to the second. Alright, let's take a look at this. Here we go. So we have two parallel lines and we have a transversal. Okay, and look what it says. Let's go ahead and call these lines, let's fix this here, make it red. We're going to call this A, L, and M, and we're going to put a right angle symbol right here. Okay, now please look what I put over here carefully. Please watch this, students. If a transversal is perpendicular to one of the parallel lines. So if A is perpendicular to L and L and M are parallel, then you know for sure that A is also perpendicular to M. Okay, now let's look at this very carefully. First of all, you must have two parallel lines, and we have that. Second of all, you must have a transversal that's drawn in such a way that it's perpendicular to one of the lines, and here it is. A is perpendicular to L. So if, students, you have two parallel lines, which we do, and if, students, your transversal is perpendicular to one of the lines, then it's also going to be perpendicular to the other line also. So I can state A is perpendicular to M. And that's what that theorem is saying. Okay, I'll pause just a second and give you guys a second to finish writing this down, okay? And then we're going to move on. Okay, now students, I do need to erase this, so if I'm going too fast, have the supervising teacher do a little, they can pause it for you, whatever they need to do. I need to get this moved here real quick. There's a reason I'm doing this, and you'll see in just a couple minutes, but okay, there we go. Now let's continue on, and let's prove Theorem 3.6. So in your notes, I would like you to make note, put something like proving Theorem 3.6 or something like that. Now, before we do that, I want to teach you guys something I've never taught you before that you really need to know. Okay, so here it is. If we're going to prove, now please listen to this, students. If we're going to prove Theorem 3.6, you're allowed to use any previous postulate or theorem that we've learned or definition the whole year. So see if this makes sense, students. Please listen to me carefully. If we want to prove Theorem 3.6, can we use postulate 15? Yes, because we learned it first. Can I use Theorem 3.7? No, I cannot. Now, let's say I wanted to prove Theorem 3.8. Okay, now listen to me. Could I use Theorem 3.7 in my proof? Yes, I could. Could I use Theorem 3.6 in my proof? Yes, I could. Could I use Theorem 3.9 in my proof? No, I could not. So, understand, as I'm getting ready to prove Theorem 3.6 in a second, I cannot use these theorems down here. Now, I can use postulate 15 and other theorems and postulates I've learned throughout the year, but I cannot use these because they come after that theorem. So do understand that, okay? All right, here we go. Let's go ahead and prove Theorem 3.6. Okay, students, here we go. Now remember, the first thing you do when you're proving a theorem is you first of all draw your diagram, okay? So we have two parallel lines that are cut by a transversal. So let's go ahead and draw our picture here. Let's go ahead and draw our parallel lines, students. Remember, when you're proving a theorem, the first thing you do is you draw your diagram, okay? So there's our parallel lines, and there's our transversal, okay? Now, we're trying to prove that alternate interior angles are congruent, okay? So I'm going to go ahead and put a 2 here and a 3 here. We're going to try to prove those two angles. Now, obviously, I've taught this math for years, and I've done this proof before. I am going to need to put a 1 right here, and you'll see why later. So we're going to put a 1 right here, okay? Now, let's go ahead and call this A, L, and M. So there. Step 1, when you're proving a theorem, is to draw your diagram. Now, step 2 is to come over here and you write your given. Now, your given is your if part. So you're given two parallel lines. So I have L parallel to M, and they're cut by a transversal. So comma A is a transversal. Very good. Now, the proof part is always your then part. So I'm proving the alternate interior angles are congruent. So I'm going to prove that angle 2 is congruent to angle 3. I don't think you students would argue with me. It's obvious angles 2 and 3 are alternate interior angles. Now, the next thing we do is we brainstorm. Now remember what I just taught you guys a couple minutes ago, students. Remember, if I'm proving theorem 3.6, I don't have to use postulate 15, but I'm allowed to if I want to, and I'm definitely going to. Look at this. If two parallel lines are cut by a transversal, I know that my corresponding angles are congruent. So let's brainstorm here. I know that I can state that angles 1 and 3 are corresponding angles. I can state that, okay? I can definitely state that. And then I can state that they're what? Congruent. Can I not? That's postulate 15. When two parallel lines are cut by a transversal, the corresponding angles are congruent. Now let's see. Hey, what about this? Can I not state that angles 1 and 2 are what type of angles? Vertical angles? Sure, I can state that. Well, if angles 1 and 2 are vertical, I can also state that they're congruent because we have a theorem or a postulate that says that all vertical angles are congruent. So we're really doing pretty well so far. I mean, look what I have right here, students. I have angle 1 is congruent to angle 3. Angle 2 is congruent to angle 1. Look at this. I have transitive. I have angle 2 is congruent to angle 1. And angle 1 is congruent to angle 3. So I could definitely state that angle 2 is congruent to angle 3. And that's what I'm trying to prove. Now, I know I make this look pretty easy, and of course I've thought these out ahead of time and all that, but it really is true if you'll learn to brainstorm and just look at what you're given and look at the past postulates and theorems that you have to use. Sometimes the proof will fall into place pretty easily, okay? So let's go over this again. I realize right off the bat that 1 and 3 are congruent. They're corresponding angles. Postulate 15. And next I realized that angles 1 and 2 are vertical, and so they're congruent. And then once I see this, I can definitely use transitive property to state that angle 2 is congruent to 3. So I think I'm pretty ready to go ahead and do this proof. So I'm going to go ahead and put ST for statements, and I'm going to go ahead and put REA for reasons, and here we go. Okay, number 1, we always put our given, so real quick, L is parallel to M, comma, A is a transversal, and that's your given. All right. Now next, I'm going to state that angles 1 and 3 are what type of angles? Corresponding angles. And so my reason would be definition of corresponding angles. I mean, the reason that I know that angles 1 and 3 are corresponding is because definition of corresponding angles, okay? And then I'm going to state that angle 3 is congruent to angle 1, and the reason would be postulate 15. I like to put this instead. I just put corresponding angles congruent of parallel lines. Now you can put postulate 15, that's fine, but I'm going to put corresponding angles are congruent parallel lines. Okay, all right, moving on. Now, number 4, I can definitely state that angles 1 and 2 are what type of angles? Vertical angles. How can I do that? Well, because of the definition of vertical angles, okay? What is the definition of vertical angles? Well, when two lines intersect, the non-adjacent angles, the two angles across from each other, are vertical angles. So I can definitely state that 1 and 2 are vertical angles. Next, I can state that angle 1 is congruent to angle 2. Can I not? And the reason is, well, we have a theorem or a postulate, I forget which one it is, but it says vertical angles are congruent. And we're cruising right along, guys. And now, let me put it up here. We'll put step 6 up here. So here's step 6 right up here. Look at this. Look at step 3. Angle 3 is congruent to angle 1. And look at step 5. Angle 1 is congruent to angle 2. Now, students, please listen. Please listen. You cannot use the substitution property when you have what symbols? Congruent symbols. But we learned this about a week ago or some time ago. We learned you can use what three properties with congruent symbols? You remember? You should know. You can use the symmetric property with congruent symbols. You can use the reflexive property with congruent symbols. And you can also use the transitive property with what symbols? Congruent. So look what I have. 3 is congruent to 1, and 1 is congruent to 2. So I can state that angle 3 is congruent to angle 2. And what property would that be? That would be the transitive property of congruence. And there it is. I mean, angle 3 congruent to angle 2, in my opinion, is totally fine. That's the same thing as 2 congruent to 3. So we did it. We proved theorem 3.6. Now you're responsible for this on a test or a quiz. Make sure you know how to do this, okay? And remember, on tests and quizzes, I will tell you what you're going to have to know, okay? But this is one thing you should be familiar with. Also, students, there's something else I wanted to say about this. Oh, in your homework, you're going to be asked to prove, I think, 1 or 2 of these theorems, okay? So really work hard on that and try to get it on your own. If you can't, then use the homework help video. That's totally fine, okay? Okay, you're doing a good job today. Let's finish this up. We've learned 1 postulate. We looked at 4 theorems. Then we've looked at a proof. And now let's look at 3 problems real quick, and then we're finished for the class period, okay? Here we go. Okay, students, take about a minute if you would, please. And I'm going to give you just a minute because we have to hurry. And we're going to apply this knowledge to some math problems. Copy this diagram on your notes, and we're going to answer 5 questions about this diagram. So please quickly copy this down. This is transversal Q right here, and this is transversal P right here. And then we have 2 parallel lines here, R and S. And don't forget, the reason I know that they're parallel is because of this symbol here and this symbol here, okay? So I'm going to give you about 30 more seconds. Please quickly copy this down. I know that you want your notes to be neat, and I want them to be neat also. We do have to hurry also. So copy this down, and then copy down these 5 problems right over here, and I'll explain to you in a second what we're going to do, okay? Okay. All right, students, here's what we're going to try to do. We're going to look at each one of these situations, and we're going to choose the correct theorem or postulate that allows us to make this statement over here. Okay, so here we go. Let's take a look at number 1. Now notice they're saying S is perpendicular to P. So here's S, and here's P. Now, how do I know for sure that S and P are perpendicular like this? How do I know that? Let's look at what I know. What I do know is I have 2 parallel lines cut by a transversal in such a way that one of this transversal is perpendicular to one of the parallel lines. Now, with that in mind, let's go back to our list of theorems and postulates. Look at theorem 3.9. If a transversal is what? Perpendicular to what? One of the 2 parallel lines, then it also has to be perpendicular to the second line. So if P is perpendicular to R, then P also has to be perpendicular to S, and we call that theorem 3.9. So right here in your notes, go ahead and write theorem 3.9. Okay? All right, now angle 13 is congruent to angle 14. Well, here we go. We have 2 parallel lines right here cut by a transversal. So we're claiming that angle 13 is congruent to angle 14. Well, those two angles are called what, students? Alternate interior angles. Let's see what we got here. Here it is, right here, theorem 3.6. If 2 parallel lines are cut by a transversal, the alternate interior angles are congruent. Theorem 3.6. Let's go ahead and write that down. And students, if you're working ahead, that's totally fine. No problem with that. All right. Angle 11 is congruent to angle 15. Well, here's 11, and here's 15. So we have 2 parallel lines cut by a transversal. What are those angles called, 11 and 15? Aren't they corresponding angles? Sure they are. Well, that's our postulate. Postulate 15. If two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So that's going to be postulate 15. And for those that have worked ahead and you're finished already, please be patient and please check your answers and make sure that you're right. Okay, students, take a look now at angles 11 and 16. 11 and 16. Now, let's see. Two parallel lines cut by a transversal. 11 and 16 are what we call alternate exterior angles. Let's go back here and look. And here it is, Theorem 3.8. If two parallel lines are cut by a transversal, then the then the alternate exterior angles are congruent. Theorem 3.8. So let's go ahead and write that right here. Theorem 3.8. Okay, students, now let's look at angles 12 and 14. Here's 12, here's 14, and notice those are called consecutive interior angles. And notice down here that we're saying 12 plus 14 equals 180. In other words, let me get rid of that M. In other words, 12 and 14 are what? Supplementary. Well, let's see if we can find a theorem for that. Here it is right here, Theorem 3.7. If two parallel lines are cut by a transversal, then the consecutive interior angles are supplementary. Theorem 3.7, okay? So we would put Theorem 3.7 right here, okay? Now I hope all of this is making sense, students, okay? We really need to know how to do this. You should be able to look at a situation and know which theorem and which postulate goes with these different situations, okay? All right, next to last problem, go ahead and copy this in your notes if you would, please. We want to find the measure of all of the labeled angles in the given diagram, okay? So we have transversal A, and we have parallel lines D and C. Over here, I'd like you to write down the measure of angle 1 is 30, and D is parallel to C, and we're going to find all the rest of the measures of these angles, okay? So here we go. So this angle here, I'll wait just another second while you guys copy this down. Lines D and C are parallel. A is your transversal. The angles go 1, 2, 3, 4, 5, 6, 7, 8. Off to the side, go ahead and write down the measure of angle 1 equals 30, and D is parallel to C. All right? Okay, here we go. So, angle 1 is 30 degrees. Put that right there. In fact, what I'm going to do is I'm going to use a different color here. We'll use green. So, angle 1 is 30 degrees. All right? Now, hey, we know that vertical angles are congruent, so we know that angle 6 is 30 degrees. And students, we know that corresponding angles are congruent, so if 1 is 30, whenever two lines are parallel cut by a transversal, corresponding angles are congruent. So if 1 is 30, then 3 has to be 30 because 1 and 3 are corresponding angles. Hey, I just thought of something. 6 and 8 are corresponding angles. So if 6 is 30 degrees, then 8 would be 30 degrees. Let's see here what else we can do. Let's see. Well, here's something. Remember how inside the interior angles, the consecutive interior angles are supplementary? So notice that angles 2 and 3 are consecutive interior angles, so they're supplementary. So angle 2 has to be 150. Now hold it. If angle 2 is 150, vertical angles are congruent, so angle 5 is 150. And then wait a second, angles 5 and 7 are corresponding, so angle 7 has to be 150 degrees. And then look at this, angles 7 and 4 are vertical angles, they have to be congruent, so 150 degrees. There we go. So just like that, we were able to find all the missing angles of the angles formed by the transversal whenever these two lines are parallel. If we know just one angle, it's really not that difficult to do, okay? So we're just practicing over and over and over again, students, the relationships between the corresponding angles, the alternate interior angles, the alternate exterior angles, and the consecutive interior angles, okay? Okay, all right, let's move on to our last problem here. Okay, students, go ahead and copy this diagram on your notes if you would, please. We have parallel lines K and L. So parallel lines K and L with transversal N. So go ahead and copy that in your notes if you would, please. And then this angle right here is 2b minus 30. 2b minus 30. This angle here is angle A. And this angle here is angle B. And then notice we have the parallel symbols right here, okay? So K and L are parallel, all right? So go ahead and copy all of this in your notes, students, and then let's find the values of A and B, all right? I'll give you just a second to copy this down. Okay, students, think about this for a second. We know that this angle right here, or at least we should know this, and this angle here are called what? Corresponding angles. So whenever we have two parallel lines cut by a transversal, corresponding angles are not supplementary, they are congruent. So I can take this top angle here, which is 2b minus 30, and I can set it equal to its corresponding angle b. There we go. And now we're ready pretty quickly and pretty easily to solve this equation, okay? I'm going to bring this b over here, and when I bring it over, it becomes a negative b. It was a positive b over here, so a negative b. I'm going to take this negative 30 and bring it over. It was a negative 30, now it's a positive 30. All right, bring down your equal sign. So 2b minus 1b would be b, and bring down your 30, b equals 30. So there we go. So we know this right here would have to be 30 degrees. So there we go. Now students, think about it. This angle here and this angle here are called consecutive interior angles. And remember, whenever two parallel lines are cut by a transversal, their consecutive interior angles are not congruent. They're not congruent. Sorry. They're supplementary. So if this angle here is 30 degrees, then A would have to be 150, because 150 plus 30 is 180. So angle A equals 150 degrees. Okay? Now, the main things that you need to take from this video are the following. Make sure that you understand these 5 truths, 1 postulate and 4 theorems, okay? Make sure you know very well, and make sure you can find very quickly alternate interior angles, alternate exterior angles, consecutive interior angles, and corresponding angles. Okay, make sure you can find all of those very quickly. Make sure you know how to prove theorem 3.6, and in your homework, when you do homework, you are going to be asked to prove 1 or 2 of these. Make sure you work really hard on those and try to figure them out on your own, okay? All right, that's it. If you guys have any questions, don't hesitate to contact me about the video if you have any questions.